Alright, so the project is gonna be on graphing functions using calculus. I'm gonna use a lecture part first, and then I'll have two examples at the end. 9 main steps for graphing is domain, intercepts, symmetric, asymptotes, interval of increasing and decreasing, critical points, concavity, inflection points, and sketch. First one, and one of the most important one, is domain. Domain is basically your x values on your graph, so this is the part that you must get right, otherwise you get all of your graph and all of your work wrong. So let's say on an example of the graph of x squared that bounded between -4 and 4, you have the graph looks like this. So you know your x value is bounded from a number to another number. There are some tricky parts for domain, that is rational functions and radicals. Here are some examples. So we know that if the radical is in the denominator, we have to set it greater than 0, but if it's in the numerator, so you have to put it on the equal than 0, because there can be 0 as well. As you can see, these are the three options that you can have and you can get your domains from. The second is going to be intercepts. Intercepts are actually pretty easy to calculate. As you can see, we have some x-intercepts and y-intercepts in the graph shown. The x-intercepts, you need to put your y value equals to 0. Actually, you put your functions equal to 0 and then you find your zeros. So basically, as you can see, that are marked by red, your y values are 0, and then you have a -2 and a 3 on your graph that are x-intercepts. The y-intercepts are gonna be x equals 0, so you plug in 0 for your x's and then you will get -6 over -1, which is 6. So you have one y-intercept which is 0 and 6. The next is gonna be symmetric. We have two kinds of symmetrics. Symmetric about the y-axis. As you can see on the red line, the graph is kind of half from y-axis. These graphs are called even functions, and they're symmetric about the y-axis, which means f of -x will be f of x. Okay, on the next example, it's x cubed. As you can see, the graph is shown, but this time we have an odd function that is symmetric to the origin. That means f of -x equals -f of x. That means it's symmetric about the origin, not the y-axis. That's the difference. The next one is asymptotes. So we have two parts of asymptotes: vertical asymptote, which is vertically, and horizontal asymptote. We're going to take a look at vertical first. As you can see, the vertical is your denominator set equal to 0, then you'll get a 2, so your asymptote will be on 2. Here's another example. Just because we have an x squared, we have an xx squared on the radical, we'll get a rad 6, negative rad 6 and a rad 6 on our vertical asymptote. The second part is horizontal asymptote. There's a right way and there's an easy way on this. So first we'll try the easy way. So we get the highest power. If we'll take a look at highest power, if they're equal, it's just the coefficients, which is 4 over 2. As you can see, it's only 2. The next one is when the power on your denominator is higher than your numerator, and that will be your horizontal asymptote about the x-axis. That's always true. The third part is when your numerator power is higher. So that in this case, you don't have any horizontal asymptotes. Now let's get to the right. So according to fourth theorem, what we need to take the limit as x goes to infinity and -infinity of 1 over x to the power of r. So what we do is, let's say in this example, you see we already know that the answer will be 3 over 5 because the highest power are the same. So if you want to get the long way and the right way, how we do is we take the limit, and as you can see, we take the highest power and then we divide the whole thing by the highest power. So the functions that you see, they have the x on the denominator, they go to 0. So what we left is 3 over 5. Increasing and decreasing intervals. Okay, so I'll show you briefly of the rules of the first derivative that we can take. These are the most interesting one is the product rule that we're gonna use, and we don't have to forget the chain rule. We're gonna use these rules to find our derivative and set it equal to 0. So when we set it equal to 0, we get some points. Let's say on this example we got 0.0 and 0.2, and then we need to make a sign chart in order to find where our graph is decreasing and where it's increasing. So what we do is we put the functions, let's say on this example negative x plus 2, we plug in points to see where it's decreasing and when it's increasing. On the first column you will see that there is a 0 at 2, so anything more than 0 will get, more than 2 will get a negative number, and then we do the same thing for x cubed. And then on the third column you will see the final increasing and decreasing chart. So whenever you have a negative for your f prime, which means your graph is decreasing. I'll show you on the next picture. So we have a positive from 0 to 2, so that will be our increasing interval between 0 to 2, and then the decreasing will be negative infinity to 0, 2 to infinity. I'll show you what the graph looks like in here. As you can see, from negative infinity to 0 it's decreasing, and from 2 to infinity is decreasing as well. The only increasing is from 0 to 2. Okay, the next one is concavity. So the concavity is basically the second derivative, where we find, let's say here's our graph, we find the first derivative, which is this, and then we find our second derivative, and then we set that equal to 0, and then these will be our inflection points where we've set our second derivative equal to 0, and then whenever we have a concave up, which means that goes from decreasing to increasing, so we have something like a U that is, we can hold water to it, and that's a minimum of our graph, and the concave down is a maximum as well. So here's a graph of summary of the how f prime affects our f graph and how f double prime affects our graph. The next will be the inflection point. The 8th step is inflection point, which is what we do is the x is actually the zeros that we found on the second derivative, and then the f of whatever number we found will be our inflection point, which will be a coordinate on our 2D graphs, which is x and y. So we just have a brief summary in here. F prime of our function, whenever it's negative it's decreasing, whenever it's positive it's increasing. And for the second derivative test we have a concave up, which is a minimum, and concave down, which is a maximum. And then for our sketch, that's the final step. We have two ways to sketch our graph. The first one would be plug in points, and the second part will be with all informations that we have. We can find our graph, the highest power of our graph, and find it. Let's say the first graph from very left top, it's just x equals a constant, and the third one is the absolute value of x. Second column left is x2, second column second is x squared, rad x, root 3 of x, and so on.